Hi everybody, so if I put an electric current down a coil of wire, it'll set up a magnetic field, and that's what a solenoid or an electromagnet is. Now the minute I turn that current off, of course the magnetic field collapses, but as it collapses it drives an electric current, and in electronics terms that's what an inductor is. Now an inductor is a way of storing energy in a magnetic field in an electrical circuit. But there's another way, and that's in a capacitor. In a capacitor it stores the energy in an electrical field, but when the electrical field collapses it again pushes a current. If I attach these two together, so I have an inductor connected to a capacitor, one will push the other forever. Unless of course there's resistance, and in a wire there's resistance, and so they die out, and it's called a tank circuit or a ringing circuit or an oscillating circuit, and it will push that current backwards and forwards as the energy is first stored in a magnetic field and then driven to store in an electrical field. And they're absolutely fascinating circuits used all over the place, and it occurred to me that there must be a mechanical equivalent of this, and of course there is. If we take a flywheel and a spring, we can do exactly the same thing that we were doing with an inductor and a capacitor. In a tank circuit, the current is stored in the electromagnetic field in the inductor. As that collapses, it's storing the voltage in an electrostatic field in the capacitor, and the two oscillate between each other. In the mechanical version, then the flywheel is storing the energy, and of course that gives a push to the spring. When it goes round, the spring returns that push by giving a little flick to the flywheel, and so it too is oscillating away. Now I didn't come up with this. This is by Bailiwick 1, and he called it his spring-powered motor or the dominant flywheel, and I'll put a link to that in the bottom and the description bar so you can see the original video where this came from. But in the video this thing just ran and ran and ran, and of course I was immensely interested in that and thought I'd have to give that a go of making my own copy, because basically it's little more than a flywheel that's free to spin and a spring. Bailiwick made his from spare parts in his part box, so I thought I'd turn to Tinkercad and draw up the bits I needed in Tinkercad. As you can see, it really isn't very many parts. It's basically a cradle, so let's put that together. So I printed those bits out, and to make this I took a barbell wedge. Now that bit there is a plug for the centre of the barbell, and I just pushed it in so it's a very tight fit. If you're going to make this yourself and you choose a different barbell wedge, that plug may not fit, so you might have to resize it. So once we've got our flywheel, then I took this section here, and of course what I've put in there is a pin. It's a pin for shelf support. It's 6mm by 25mm. I've used this before, so I had some of them kicking around, and I've got a bit of 8mm bar, 50mm long right there, and that will thread through two skater bearings, 22mm by 8mm, which go in these holes here, and that will thread into there to give me the support. Now we want to just push it away a little bit, so I've got two 8mm washers right there. They go on first, then your barbell goes on, then you drop another couple of 8mm washers in there so it spaces it properly, and then we push on our other bearing, and then you'll notice there's two caps. They're 3mm. They go over the bearing once the bearing's pushed in, and they push the bearing down to stop it moving in and out. A bit of super glue to hold those on, and that is your flywheel put together. Now to hold the spring we've got this bit here, and that bit will glue on there, but we're not quite sure where it's got to go yet, so there's a little bit of sliding around to do. And for the spring I'm using a standard hacksaw blade, and you stuff the hacksaw blade in the slot there and position it so it's near to here, and so that it just comes to the edge there, so that when that turns it just hits the spring, and then the spring obviously will push it back up again. We need to position, as I say, so it's just a little bit away from there, and then we can glue all that in place and we'll have our spring. And once we've glued it in, this incidentally is 120mm long. Once we've glued it in, then it's ready to go. Now you notice there's some magnets there. They act as a weight, and that weight is a tuning weight. And when you get the tuning right, it's amazing actually. So you've slide those up and down until you tune it, and it'll change in its tuning for things like length of spring, material of spring, how thick the spring, how much weight there is, how heavy your flywheel is, etc, etc. So there's going to be variety in this, but that weight allows you to tune it, and all we have to do then is give that a spin. That's awesome. Anyway, I hope you enjoyed the video. If you fancy giving that a go, then the files are in Thingiverse, and of course the link is in the description below. Thank you very much for watching, and please do remember to like and subscribe.